All right, looking at example 3, let's say a survey found out that out of 520 businesses, 35% had fired workers for misuse of the internet. So first question, how many of the businesses surveyed had fired workers for misuse of the internet? So what we want to figure out is what is 35% of 520. So go ahead and do a quick multiplication, writing your percentage as a decimal, and you will find out that that is 182 businesses that had fired someone for misuse of the internet out of those 520 businesses. Okay, well, why is that important? Well, because in order to run this test on our calculator, remember in order to find the confidence interval on our calculator, we need to know what X is. How many businesses responded in such a manner? In this case, yes, I fired somebody for that. We need to know the number of businesses, not the percentage or proportion. So this time we're going to find a 90% confidence interval for the true population proportion of businesses that have fired someone for misusing the internet. So again, we're going to go for a 1 proportion Z interval. So stat, arrow over to tests, and then down to 1 proportion Z interval, again, probably around A somewhere. And we've got to enter the values of X, N, and our confidence level. Now X, this is where we had to know that 182, okay? How many out of the 520 businesses? So that's where that 182 comes in and why we needed to know. N is our sample size, 520, and our confidence level in this case is 90%. So get that data entered into your calculator, and remember, enter your 90% as a decimal, okay? And we will get an interval, rounding to 3 decimal places, of 0.316 to 0.384, okay? All right, now for the margin of error, again, we can go one of 2 ways. You can subtract the upper boundary minus the lower boundary and divide by 2. Or, since we know that 35% is smack dab in the middle of that interval, you can either take the upper boundary minus 35% or 35% minus the lower boundary. Take your pick. For me, I'm going to do that upper minus the point estimate of 35%, and I'm going to get 0.034 or 3.4%. So what is the statistical meaning of this confidence interval? Okay, well, in this case, there's a 90% chance, because remember we did a 90% confidence interval. The true, and I'm going to write this one as a percentage, so I'm going to do percentage of all businesses that have fired someone for misuse of the internet is between, and again, I'm going to take that confidence interval and I'm going to write those in percentages because this time I use the word percentage. So between 31.6% and 38.4%. Okay. Now, thinking back to what we talked about in the last section a little bit, what happens to the confidence interval if we increase the level of confidence? So remember, right now, we're at 90%. Okay, if we're going to go to 95%, we want a bigger area to hit, so the confidence interval will get wider. Okay, the confidence interval will widen. If we want to go up from 90 to 95 or 99% confident, we've got to have a bigger target. Okay, so what does that do to the margin of error? Okay, so remember we had our 35% right here in the middle, and we tacked on this margin of error at our 90%, okay, if we're going to go 95%, remember, or 99% or whatever, okay, greater than 90%, we need a bigger target. The margin of error is just going from one direction or the other. Well, notice what happens is that margin of error gets bigger. Okay, so as your confidence interval widens, it's widening because you're allowing room to make more mistakes. Okay, you can be less accurate, means a bigger margin of error. All right, so last one here. Find a 98% confidence interval for the proportion of businesses that have fired someone. So we're going right back into the same test that we just did. And it should actually even hold in your calculator. The values will still be there. All you need to do is change your confidence level to 98%. And remember, what we're expecting is that this interval will get wider. Okay, so we're expecting the low of 31.6% to be lower and the high of 38.4% to be higher. And indeed, we find that that's what happens. On the low end, we've got 0.301. And on the upper end, 0.399 by the time we round. And so it did indeed widen, okay? We have a bigger margin of error.